Now this illustration deals with connection to the equipment grounding conductor in accordance with NEC 410.44. And the purpose of this change mainly is just to warn the electrician as well as the designer that an equipment grounding means of some sort in accordance with 250.118 must be provided to ground a metal box and the fixture properly to clear a short circuit or a ground fault if one should occur. And that's all this illustration is trying to illustrate to the user of the NEC. Now this illustration deals with the disconnecting means for fluorescent or LED type luminaires that utilize double end type lamps. Now the main purpose of the change was to let the designer installer know that the requirements for fluorescent or LED luminaires that utilize a double-ended type lamp configuration was required to have a disconnecting means. And so we don't want to install this type of lighting and stuff without providing a disconnecting means, which in some cases was being done due to the configuration of disconnect and controlling of these units. So this was just to ensure that the designer installer knew a disconnect is required by the rules and regulations of 410.71 items 1 through 3. Now this illustration again deals with GFCI protection for personnel in the kitchen area. Now notice at the very top of the illustration, let's look at the top of the illustration, and a listed Class A GFCI protection required outlet is required in accordance with 210.8A. And of course you need 2 circuits in the kitchen, small appliance circuits, which we have here. The definition of a kitchen's in Article 100 on page 45. A feeder GFCI protection is also defined in Article 100, 215.9 defines a feeder and GFCI protection. And then notice your receptacle locations is outlined in 210.52A4 on page 87. And we also suggest you review pages 299 and 300 to give you more information about these receptacles located in the kitchen area. Now, the main purpose of the change, it's a revision, and it was added by the code panel to recognize that a Class A GFCI circuit really is different than a Class B GFCI, but it kind of implements that if you have a receptacle, as you see there at the sink area below it, that if it's within 6 foot of the inside wall of that sink, it needs to be a GFCI protected receptacle. But also it just basically states that regardless of whether the receptacles serve the countertop or not, they need to be a GFCI protected type receptacle. Now this illustration deals with ceiling suspended paddle fans. And this is a basic rule that we're all aware of if we're designers or installers. But basically you just can't have a ceiling fan even if you put it on a GFCI if you penetrate and install it in the space 8 foot vertically and 3 foot horizontally. That is a code violation, as you see in the blue type. Violation if below ceiling an 8 foot or 3 foot zone above bathtub or shower space or bathtub space in accordance with 422.18b. So that's what this illustration is further illustrating, because we're finding too much of this out in the field according to the inspection authorities, that ceiling fans are installed over bathtubs and hydro massage tubs because the owner wanted it and they put it on a GFCI, but the code at this time does not allow that. And that's what this illustration is illustrating to the user of the NEC. Now this illustration deals with the installation of cables in the wall. heating cables. And basically, this purpose of change deals with this type of installation where you have heating cables in the wall where, due to the environment and the location where you have this installation is very cold, see. So what they're basically saying here then, that the heating cables may be in the concrete or in the wall, and ground fault and AFCI protection required for electrical heated walls. And this is one of the main rules, and then of course this is up to a height of 4 foot is how you would install them. And basically that's what this illustration is all about. If you're installing heating cables in the wall, and how are they exactly to be installed and protected, and that's what this illustration is illustrating to the user of the NEC. Now, this illustration deals with reconditioned motors in accordance with NEC 430.2, and that's the main purpose of the change, is just to address reconditioning requirements of motors. And basically, if you look at the call out here at the very right-hand side top of the motor, it says these manufacturer specifications, should be used when you recondition a motor. And the call out at the bottom left-hand side of the illustration and the motor, reconditioned motors have to be identified in hazardous classified locations and labeled as such. But mainly, that's what this illustration is trying to get over to the user of the NEC, is what specifications are national recognized standards, such as UC, UL 845 and 674 in the little table above the illustration. Use whichever is available, and that's what this illustration is trying to get over to the user of the NEC. Now, this illustration specifically deals with the nameplate values in accordance with NEC 430.6A2, items 1 through 3. And now, note 1, it talks about low speeds, less than 1200 RPM. Use the nameplate rating, see. High torque hand pumps or multiple speed motors, use the nameplate to size the components A through C that you see there. Conductors, switches, current ratings of the branch circuit, ground fault protection, that kind of thing. And then note 2 says use the nameplate for the following large motors. And part 15, Roman numeral 15, should be used instead of the current rating. And I believe that's Roman numeral 14 instead of 15. And then the controller with separate overload protection, 430.6A21 is listed. If you have an MCC, for example, the overload protection may be provided within the MCC in the controller there in accordance with 430.6A2, items 1, 2, or 3, whichever C may be applicable. And that's the main purpose of the change. When does the designer and electrician use the table currents in the back of the Article 430 for single phase and three phase, as we mentioned, 430.248 for single phase, three phase, table 430.250, the starting current of these motors, 430.251A and B, or do we use the nameplate? And that's what this illustration is illustrating to the user of the NEC, when to use the nameplates values to size these components. Now, this illustration deals with conductor ampacity and motor rating determinations in accordance with NEC 430.6A1 and exceptions 1 through exception 3. Now, let's just look at the left-hand side of the information down with the arrow pointing to the motor, bottom side of the illustration. And these table values are used here. You have to go to the table values for single-phase or three-phase motors like we've always done. Single-phase motors, table 430.248. Three-phase motors, 430.250. Now, the exception 1 that you see here now, and the blue typing, we use the nameplate current to size all the elements of the system for the motor in accordance with 430.22b as in boy. Now, the exception 2 talks about, shady pole motors, permanent split capacitors, blower type motors, and that kind of thing. But notice we use a nameplate here to size the disconnects, the controller, ground fault protection devices, separate overload protection, and so forth, items 1 through 4. The exception 3 now, you would use the nameplate. And the nameplate then for these motor operated appliances for your disconnect, controller, ground fault protection devices, and the separate overload protection, again, we'd use the nameplate. And basically this purpose of change is wanting to clarify when the user of the code designs and install motor circuit systems that they know where to pick up the current, full load current, to design these components that you see in the illustration. Is it table currents or appliance nameplate currents or motor nameplates currents? That's what the illustration is illustrating to the user of the NEC. Now this illustration deals with table 430.52, which is an existing table number in the 2020 NEC. It has been renumbered and relocated. It's table 430.52C1. And that's what this illustration is illustrating, and it's the purpose of the change also. But for the changes now for you to review and editorial and so forth here, look at the note 2 below the table and see what took place. And also look at the lowercase a and b that's below the table and see what took place there. And then you have this really, you're in good condition what took place here. But mainly it's no big deal. It's just a relocation and renumbering of the existing table 430.52 to a new number 430.52C1. But I don't see any big change there that's going to affect the way we design the overcurrent protection device to allow a motor to start and run. And that's basically what this illustration is trying to illustrate. Now this illustration deals with instantaneous trip circuit breakers in accordance with NEC 430.52C A and B. This section has been renumbered, but notice in the boxed in information, it kind of explains what took place here. Application of 430.52 C3B1 and 2A through C. And basically, B1 states that the setting cannot be any greater than 430.52C1 if the motor will start. And if that 1100%, I believe in there, will not allow it to start, you could go up to 1300%. And if it still wouldn't start and accelerate the load, you could go up to 1700%, which many of the high efficiency, motors will require. And then look what was added. Under engineering analysis, table 430.52C1 value can be bypassed per C to 430.52C132 to allow a motor to start and accelerate the load under an engineering analysis that takes place. Now, that's the difference that has taken place with this renumbering of this section for instantaneous trip circuit breakers, and that's what this illustration is illustrating to the user of the NEC. Now, this illustration deals with sizing the overcurrent device to allow a motor to start and run. And of course, it's in accordance with table 430.52C1 and outlined in 430.52C1A and B such requirements. Now, the main purpose of the change is the round down size, the round up size, or the maximum size in accordance with 430.52C1A and B. Now, kind of reviewing this illustration, then notice we want to get the full load current of the motor. So step 1, 430.6A1, would send us to table 430.250 for this full load current rating to use to size the overcurrent device, 65 amps. Step 2, we're applying the 250% for this motor that was selected from 430.52C1. And then, of course, 250% application of the 250% times 65 would give 162.5. So we would round down to the minimum size. Now, in the table, you can always go smaller. We'd come up with 150. Or we could automatically round it up to 175. If the motor still would not start and run, we could look at 430.52C13 on page 349, approximately in the NEC. And if the full load current, which you see in step 1, is 100 amps or less, it is 65 amp, I could use 400%. If it's over 100 amps, which it's not, I could use 300%. So applying the 400% rule times 65, I'd come up with 260, and there's no exception to let you round up or any permission, so I'd round down. I could use a max of 250 to allow that motor to start and run, and that's what this illustration is really illustrating. Now, this illustration deals with a title head, Energy from More Than One Source, in accordance with 430.113, exceptions 1 and 2. And the code panel just accepted this revision to indicate to the user of the NEC that you must identify when you have more than one power source in a motor circuit. Now, for example, you have to remove all power from the disconnect that you see in the illustration, note 1. Then note 2 makes it clear if you have a class 2 circuit, there's not any requirement to identify it. Now, we know we find this in Article 100 of NFPA 70E under electrical hazard. In other words, a class 2 circuit's not a hazard to you. So a permanent warning sign must be placed on each disconnect where you have more than one power source entering. And as you see in the illustration, I could have extra contacts in the disconnect. When I disconnected, it would disconnect the power to the motor plus the control circuit, if it's more than a class 2 circuit. And that's what this illustration is illustrating to the user of the NEC. Now, this illustration deals with the sizing of the conductors to adjustable speed drive that's rated over 1,000 volts supplying it. The size of the conductors is in conjunction with NEC 43205A and B. Now, you know, in the previous editions of the code, the last part of any article dealt with high voltage, such as overcurrent protection. The last part of Article 240 dealt with that. Grounding, it's still that way. The last part of the article, which I think is Part 10, deals with systems over 1,000 volts. Now, some of the articles will still have the high voltage requirements at the back of the article. If you can't find it in the 5 articles that now deal with high voltage, such as Article 235, 245, 305, 315, and 495, we would pick the information up at the last part of the article, such as we do for adjustable speed drives over 1,000 volts. That's the last part of Article 430, which is Roman numeral 10, approximately on page 360. And all this illustration is saying and trying to relate to the user of the NEC is that a system over 1,000 volts, you still have to increase the input of the drive, which you see in the illustration, 118. You have to multiply that by 125%, which is in your step 1 for sizing the conductors, come up with 147.5, and that would require a 1/0 conductor from table 310.16 in the 75-degree column. And that's exactly what this illustration is illustrating to the user of the NEC. Now, this illustration deals with the disconnecting means in accordance with NEC 43208. Now, the purpose of change was to make it clear that the disconnecting means to disconnect an adjustable speed drive system and the disconnect to disconnect the motor has to be at least 100% of the rating full load current of the motor. Now, like the overcurrent protection device, they can be sized at 100%, which is verified in 235.408B, and I believe that's around page 121 of the NEC. It says 80% rule doesn't apply to overcurrent protection. Because of the high voltage, you don't have to put the 125% on and derate the 80% of the overcurrent device loading, see. So when you look at the bullets here, the main thing is the note 1. The disconnecting means shall not be less than 100% of the rated current of the motor per 430.208, and that's basically the requirement. And then the note 2 tells you the same thing for the motor. So the adjustable speed drive motor, the disconnect for the motor itself, when you look at this rule in 230.208, it's just 100% for the disconnect for both. And that's what this illustration is trying to illustrate to the user of the NEC.